Hi everybody, I'm Nick Clinton. I'm on the Earth Engine Developer Relations team. And I don't know about you, but I'm stuck at home right now and it seems like a good time to be recording and watching videos. So that's what we're going to do. And in today's video, I'm just going to cover some real basic stuff about exploring imagery and image collections and discovering something about the bands and the georeferencing and the size and shape of the images in an image collection. And to make this interesting, I'm choosing a collection that I don't really know anything about, which is the Sentinel 5P collection. And so we're just going to try to find some images in there and see if we can make a composite out of those images. So here we go. So what you see here is the code editor interface of Earth Engine. And typically I start by searching for the data sets that I want. So I know I want to find some Sentinel 5P imagery, and if I just type Sentinel here, you'll see that it's already, the autocomplete has already found a bunch of Sentinel 5P data sets here. And I'm specifically interested in this nitrogen dioxide data set. So I can click on that and it's going to tell me some more information here, and it'll tell me what bands are available and some other information about the data that's in this data set. So all this looks good to me, and I want to do some more exploring once we load it into the code editor. So I'm just going to click the import button here, and you'll note that it has made an import record up in the top of the code editor, and you can see that it's really just code that is written for you. And it's just made this variable called image collection, which stores the reference to that data set. And I'm just going to rename this to something a little shorter, so I'm just going to call it S5P for now. So what's in there? Typically, the first thing that I will ever do is go to my place of interest. So usually that's somewhere around Google headquarters in Mountain View, California. So I'm just going to go to Mountain View, and here we are. The Googleplex is down in here somewhere. And now I'm just going to make a point. And I'm literally going to make a point by clicking this place marker icon in the geometry tools here. And I'm just going to drop it somewhere in my area of interest, and that's all I need to do for now. This is just a point that I can use to spatially filter this collection if I need to. And so now I can make a new variable. I'm going to call it filtered, and but I'm going to spell filtered right. And filtered is just going to be that S5P collection filtered to that point. And note that that point is called geometry in the imports. Actually, let's rename that so it makes more sense here. So I'm going to filter bounds to that point, and let's just see what happens here if I do that. This may or may not be a necessary step, and I'll explain more about what I mean by that in a second. But if these are global composites, then filtering by location using filter bounds is not a necessary step. So let's just try to find out what we get from that. And I don't want to try to print too much stuff, because if you try to print too much stuff, specifically more than 5,000 things, you're going to get an error. So I'm just going to limit this to about 10 images, not about, exactly 10 images. And let's just see what happens. And so when I click the Run button, you'll note that an image collection appears in the console here. And let's see what's in there. And so I'm just going to expand this with this little zippy icon here. Note that there's a list of features here. So every image collection in Earth Engine is also a feature collection, and that's why the images in this image collection show up in this features attribute or property of the image collection. And here are a bunch of images here, and just looking at these file names, this looks to be 2018 0719, so that's I'm guessing that's July 19th, but I don't really know. But we can check that by expanding one of these images here. And it looks like we have two July 19th images here. I'm sorry, 2018 0719, 2018 0719. And this looks like different processing versions, maybe. Let's just sort of be aware of that when we're looking at this. So if I expand this image, you'll note that it's, first of all, it's telling me that there's a list of bands here. And so we can inspect this list of bands, and this looks kind of interesting. Specifically, I'm hoping this column number, NO2 column number density is going to be what I want, but we'll know more in a second. And also note that there are a bunch of properties here. So sorry, before we get to properties, let's just take a close look at this band because there's some more information here that I want to discover. So first of all, note that it's got projection is EPSG 4326, or the coordinate reference system is EPSG 4326, so unprojected data in latitude and longitude coordinates. And let's just take a look at this transform here. And so this is telling me the location of the upper left here, and it's telling me the resolution in decimal degrees, and that doesn't mean a whole lot to me. Yeah, I'm not going to embarrass myself by trying to guess how many meters that is. We can discover that in a second too, and I'll show you how to do that. But first of all, I just want to note that you can sort of do some looking around here in the attributes of the bands themselves. And now I want to check out the properties of the image. And I'm noting that there's all kinds of interesting stuff in there. You might want to filter on some of this stuff if you want to. But what I'm really looking for here is the footprint. And specifically, I'm looking to see whether this footprint, I'm looking to see if this footprint is a global footprint, in which case you would expect to see minus 180 and 180 and 90 and minus 90 in there. But it's not, obviously. This is a smaller footprint here. So what that means is that this filter bounds is actually doing something. And we can check that by just adding it to the map. But for now, I'm just noting that this footprint is not a global footprint. So this leads me to think that there are tiles here. And we can always just check that by changing this print statement to a map.addLayer statement. And I'm just going to select only the band that I want now. I'm going to fix all this up in a second here, but just note that I can select the band that I want. So I'm just going to copy this and paste it here, and let's see what happens when we do that. And so something is coming onto the map, and it's this blackish thing, and that's okay. And I just want to zoom out and sort of see the extent of the blackish thing. I'm noting that it's yeah, okay. So here's the extent of this tile, not tile, of these data sets. The images that we've selected from within this data set, the footprints of all these images, whether or not there are valid pixels there, the footprint intersects this point. So that's why we're getting all this stuff. And we can tighten that up if we want. But for now, what I'm going to do is I'm going to make this a little bit easier on us. And I'm going to take all this stuff out, and I'm going to start adding stuff to the filter. So we've got a filter bounds, which is what's getting us these particular images here. Now I want to filter the date too. So I'm not entirely sure what the temporal resolution or the revisit time is here. So let's just start with a whole year and see what we get. So I'm going to start with 2018 01 01 to 2018 12 31, and now we can just add this entire thing to the map. In fact, I'm just going to take out this select because that's the band that I think I care about. We can always change that later too if we want. And I'll put that right in the beginning. It's also nice to print the size of this collection. So let's just do that and see what we get and run it. This is not filter, this is filtered, and run it. And so 318 images. The other thing is that I'm a little bit wary of the duplicate dates in here. So let's just print this whole thing out again and sort of inspect this more carefully to see if there's some deduplication that needs to occur here. So here's a bunch of, okay, so these look like they are daily images, and these are, so I'm just looking at the dates here that are burned into the file name, and I'm also looking at the numbers that come after the date. So I'm speculating that that's either a processing version or a location, and if we take a closer look at these, we might be able to discover that. So specifically, if I look at the footprint of this thing, and I look at the coordinates, and now I'm going to look at the footprint of the other one and look at the coordinates, and see if I can tell something about that. And indeed, these are in different locations, as you can tell just by scanning the first few coordinates here. So I think these two images, although they're the same date, are in fact different images, as you can see here on the map. And the question is whether we could get those out as from properties. And so just scanning through the properties, we can see that there are some coordinates here we might be able to filter on. We might be able to filter on orbit, but it's not exactly obvious how to do any of that stuff here. But we're just noting that if we need to, we might be able to do that. So at any rate, I'm fairly happy with what we've got here, and if you've decided that this is going to work for you, what you can do is just sort of keep track of what you've done previously by making some comments here in the code and then just commenting all that out. So the way I do that is highlight a bunch of rows and then Command or Control if you're on a PC or a Linux box to toggle this code block, commenting on and off. So I'm feeling pretty good about what's in here, and then I've got the right band and I've got about the right date, and so what we're looking at here is making an annual composite. And so if I run this, so now I'm just adding everything that we've got here to the map. So that's 318 things here. And when you just add a collection to the map, what it's going to do is it's going to call .mosaic in the background. So this is in fact the same thing as doing this. And what happens when you do that is you create a composite in which the pixels that you get are just whatever the last thing in the collection is. So if the collection is sorted chronologically, then this is a what we call a recent value composite. But right now it's just giving you whatever the last thing is in whatever sort order the collection is in. And but it's useful because you can click on the inspector, for example, and it will tell you this is the last thing that in the collection. That's the pixel from the last thing in the collection. But if you expand objects, then you'll see more, and this is not that interesting. In fact, I forgot that I called .mosaic on this. This is not what I want anymore. I don't want to call .mosaic. I just want to let it do that for me, because then when I click, you'll note that it will show you that mosaic value, but it will also show you a whole series of data here. So here's a whole time series of nitrogen dioxide moles per meter squared on that pixel that I just clicked on. And you can also just get the list by toggling this little button here between the chart and the list. And note that in fact these are labeled by their image ID, which is quite useful for getting individual images out of here if you want to inspect one of them. But generally for that I use the objects. So now it's showing you, this whole list of objects here, and sure enough, there's the ID. And if you really want to get that out and sort of look at an individual image for some reason, you can just copy this and then paste it into a variable. So I'll just call this image check or something like that. And now I just paste that ID that I got from the console here, which is this thing right here. And I just pasted that into the image constructor. And now if you want, you can print that image or add it to the map, or sort of fiddle around with an individual image if that's useful to you. I don't know why you would want to do that, but that is how you get an individual image out. So I got this image by inspecting the objects list printed to the inspector when I click a point. So that's where you can get that image ID, again, if you really want it. But I don't really care about that. I'm just showing you how to get that image out. And this map is sort of starting to look the way I might want it to look here, and we can fiddle with the scale just by doing a stretch. So if I stretch to 98% of the data, it's going to try to compute those statistics from whatever it can see in the map window here, at whatever scale you have displayed here. And so that seems about right. Okay, so I got something here, but this thing is not really telling me anything useful anyway, because it's a recent value composite. It's not a say a median or a mean composite. So let's see what that looks like. So I'm going to say the var mean, and watch out for this because not all these data are cloud filtered. And if you don't want to be taking the mean of clouds in here, but not knowing much about this, I'm just sort of fiddling around. I just want to see what that looks like, and so we can just do that for now. And that's a shortcut. Saying filter.mean is a shortcut for saying filtered.reduce with a mean reducer, and that's a shortcut for just saying ee.reducer.mean. So that's the long way, or you can just call filter.mean. You should get the same thing. And now we can start adding that to the map. And I think I'm done with inspecting these individual images for now. So I'm going to turn that off just so things don't get real cluttered on the map. But I will copy this statement. I'm not a very good typer, so I do copy and paste a lot. And now I'm just going to copy mean, and I'm going to put that in there. I'm not sure what the visualization parameters are yet, but I'm pretty sure that I'm going to stick something in there, so I just gave it an empty object for now. And another thing I like to do is name the layer after the variable so there's no ambiguity in what you're looking at here. Now what do I want to do? I want to actually compute some statistics and see if I can start filling in those visualization parameters. So if I stretch to 98% of the data, what am I going to get? I'm going to get this some very small number here, 2.0002. So if I just fill in a min of 0 and a max of 0.002, and let's see what happens. We could always fiddle with that a little bit. And recall that the units here are in moles per meter squared. So, and how do I know that? Because I remembered it from the metadata. So if I click on this thing and you go to the bands tab, and here it's telling me the approximate range, and it's in moles per meter squared. So that's why I'm just making this comment here so I can remember that. Now if I click run, we should have a somewhat more meaningful visualization, and that's starting to look a little bit more reasonable. You can sort of see what I'm guessing is you know, pollution basically from these industrialized areas, and including here in the Midwest and you know, Los Angeles. So at this stage, what we might want to do is convert this into some different units. So at this point, I'm starting to have an idea of what's in this data set and how things look and the ranges of things, and so on and so forth. And now I just want to sort of clean things up a little bit, so we can start zooming in and looking around. Remember, when you zoom in to Earth Engine, it's going to redo the computation at whatever scale you're at based on that zoom level. And you can discover that by clicking on the inspector, and it will tell you what the scale is. So zoom level 4, the scale is approximately 10,000 meters per pixel. So that's the data that we're using here, is selected at this scale. So the inputs are resampled and reprojected as necessary to achieve that scale, and that's what we're seeing here. And now I just want to convert this, and I want to convert it to something that's more meaningful here. So specifically, I'm just going to call this moles, and I'm going to say that the moles, so this is, you know, the number of moles per column here in the atmosphere, and I'm going to say that the moles are just the mean multiplied, multiply by this special magic image, which you can get from the static method on ee.image, and this magic image is called ee.image.pixelarea. And so that is just this magic ee.image.pixelarea thing returns the area of a pixel in meters at whatever resolution you're at, whatever scale you're at, whatever zoom level you're at. So this is converting my mean in moles per square meter to just moles per column by multiplying by this magic thing. So let's add that to the map too. And so I'm just gonna, again, copy and paste is your friend. Copy this, copy this. I don't know what the scale is anymore, so I'm gonna just do that. And I'm gonna turn this off, because I'm done with that, but we can always turn it back on again if we want. But now we're gonna get this other image, which is in moles per pixel, and I just want to fiddle again with the stretch here to see what the right scale is. And so it's a very large numbers now. This is probably not what I want either. So we can just well, let's see what we get here. Okay, so this is not doing what I thought it was going to do, so I am just going to start fiddling with this. The min is still going to be 0, and let's make the max about 100 to see what happens. And that's too little, so I can make that a little bit more, and we can keep doing this until we start getting something reasonable. And these are really large numbers, which is sort of starting to make me worry that, you know, we're going to run into some overflow if we're not careful here. So you know, I didn't have to add too many zeros, so it looks like the max is about 10,000, and that gives you a reasonable visualization. We can always fiddle with this even more to achieve the effect that we want here, but this is starting to look pretty reasonable to me. So at this stage, we can start fiddling with a palette, and the palette will add some nice colors here. And I don't know what's going to happen if I just give it an empty palette. Maybe nothing at all. Maybe it's going to give me an error. Okay, so it's just ignoring that, so that's fine. And now I just want to fill in some colors. And note that some of these collections have some palettes in their properties. So let's just see if we can find a useful palette in here. Sometimes you can find some nice visualizations that have sort of already been done for you. I can't really find that here, but There's also a code snippet, which doesn't really have what I wanted either. Let's just try printing that image again to see. There's just my image check. I'm just going to run that again and see if there's something on this image that's going to be useful. Or maybe on the collection itself, maybe. Let's just try that. So that's not working either. So I'll say print the filtered collection again and run it. And this collection might have some properties. Okay, so there's a date range, a big blob of HTML, which is the description. And okay, so here's a palette that is a property of the image collection. And it's just this list of colors here. Never mind that. So you can try to get this out of here if you want. But the problem with doing that is that then you have to call getInfo on it, because in fact this is a server-side object. So all these properties are server-side. So a lot of times it's just easiest to copy that stuff and paste it into a variable. And here's how you can do that. You can say palette. Oops, it's going to make me name this. Var palette equals this list of colors here, which I think I can just do that way. And then we'll say that the palette is going to be passed in as this palette, and whoops, sorry. Let's just put it right there and run it. And now we're starting to get a nicer looking visualization that's closer to what you might find in the examples and so on and so forth. And there's a little bit of noise here, and you might have to fiddle with the quality flags or fiddle with your filters in order to get rid of that noise. But I'm starting to feel pretty good about being able to make maps with this stuff, what the units are, what the resolution is. And oh, I almost forgot to mention, if you want to discover the spatial resolution, you can get the projection of an individual band from an individual image. And let me just show you how to do that here. So here's our individual image. Oops. Here's our individual image check. And so I'm just printing the image, but here I'm going to print something else. I'm going to print image check, copy, paste, dot, projection. And that'll give you an error if different bands have different projections, but here we've selected just one band. And so I'm just going to get the projection there. And then I'm going to call dot nominal scale on that projection. And now I'm just going to print that out, and I'm going to print this list of values here. So now it'll tell me. I don't think I need to print the image anymore, so I'll comment that. Run it, and there's the scale. It's about 1 kilometer. And so that's an easy way to discover the scale in meters. But the purpose of this little demo was to just explore some data, learn what kind of images are in a collection, what their spatial extent is, their temporal revisit time, what properties they have, and how you can use all that stuff in order to get an image that you can start using in your analysis. So that's it for today's short demo, and stay healthy.